Alright, in this video we are taking a look at solving a system of equations using the substitution method. A big heads up as to why we're using the substitution method here is this first equation. In the first equation, you can see that it is set equal to y. When you have at least one of your two equations that is set equal to a variable, as we see right here, the substitution method is likely what you want to use, because the substitution property of equality says that we can replace a variable like y in a second equation with what y is equal to. So I can swap those two pieces in and out, and I still maintain equality. That's exactly what we're going to do here. All right, so if I go ahead and get my pen, the very first thing I'm going to do is I'm going to take my second equation, and I'm going to rewrite it, but instead of y, and I'll put it in a different color for you, I'm going to put what y is equal to in parentheses. So in this case, it's negative x minus 7. That's what I replaced. Everything else stays exactly the same. Notice we have a plus 3x. We have an equals negative 13. None of the stuff in white changed. The only thing you change is to remove the one variable that we know and replace it with what it's equal to. In this case, negative x minus 7. Once we do that, we have one equation with one variable, and I can solve it. Follow your normal steps for solving, which means distribute. So negative 5x minus 35 plus 3x equals negative 13. Then combine your like terms. 5x and negative 5x and 3x give me negative 2x. Get all your x's to one side, which they are. Move all non-x's to the other side. And then we go ahead and isolate x here. That's going to give me 22. Divide by negative 2 on both sides to find that x equals negative 11. Just like equal values method and all the other ways of solving a system of equations, once you find x, you got to go back and find y. I encourage you to use this first equation. It's already set equal to y, so we know that y is negative x, and I'm going to put parentheses where x is, and I'm going to substitute my value of x, which is negative 11, minus 7, and I'll simplify that. That gives me 11 minus 7, which gives me 4. And just like the other ones, I encourage you to check it. Take these two values, plug them into the other equation to check it. So in this case, I want to see, does 5 times y, which is 4, plus 3 times x, which is negative 11, does it equal negative 13? Well, that gives me 20 minus 33, and we see that is indeed negative 13, which means my answer is correct. Now, that's not my answer. Don't box that out. My answer always comes from x and y. So we go back to our x, put that one first, x, comma, y. That is my answer. Put parentheses around it. It is an ordered pair, which means that's the intersection point on the graph of these two equations. All right, and we want to look at that. That is how you solve it using substitution method, which is essentially very similar, if not the same method, as equal values method.